Hey guys, it's Gus from LeetCode Solutions, and today we're going to be looking at the second problem that's on the online practice interview questions on LeetCode. Um, and that question is add two numbers. So with that in mind, it doesn't seem too difficult. I think we can just probably do this, and that should be okay. Let's just submit it. Huh. Alright, maybe we should try something else. Let's go to the problem description. So you are given two non-empty linked lists representing two non-negative integers. The digits are stored in reverse order and each of their nodes contain a single digit. Add the two numbers and return it as a linked list. You may assume the two numbers do not contain any leading zero except the zero itself. Except the number zero itself. And the given example here, we have two linked lists, 243 and 564. And this is a representation of the number 342. And this is a representation of the number 465. And we are adding those two to get 807. And then we are returning that as a linked list. Okay. For those of you who are unfamiliar with the concept of singly linked lists, basically you can think of it as a list where each node in the list, the only available information from that node is the value of that node and the value of the next node in line. So if we're looking at node 5 here for this list, all I can tell you about it is that its value is 5 as exhibited by this self.val, and the next value in line is 6. A good way to think about singly linked lists is basically they're code representations of a number sequence that have a specific order. Okay, so how should we do this? My very first instinct tells me that we should parse through these linked lists and add these numbers to actual lists and then work with that because it would be easier. But I don't think that's exactly in the spirit of the problem. If they wanted us to work with lists, I think that they would have just left these as lists and not linked lists. Plus, that'll also probably just add some unnecessary memory. So how should we approach it with that in mind? Well, we know that we're going to be iterating through the linked lists regardless, right? So if we do that, let's say we're looking at the first element of the two linked lists here. We look at 5. And we look at 2. 5 and 2 add to 7. And that's over here. So I guess we add that 7 to another linked list, probably the one that we're going to end up returning. Then we go to the next two, which is 6 and 4. You add those two and you get 10. Okay, so that's interesting. Because we obviously can't put a 10 here. But we can put a 0 here. And if you guys remember how to add two numbers from your first or second grade training, then you remember that you're supposed to carry the 1 once you do this. So the 1 goes to the next step. We add 3, 4, and 1, and we get 8. And just in case, I'll pop open a Word document here and draw up what I mean. We got 3, 4, 2, 4, 6, 5. Ignore my horrible handwriting. So we're going to be looking at the first two elements. I'm going to get a 7. The next two, 0, carry the 1. And any good math student knows that 1 plus 3 plus 4 is 8. So we have 807. And that's basically how we're going to be solving this. Basically going through this exact process. Or at least that's going to be the attempt. So how should we start then? Well, we know we're going to be returning a new linked list, so let's just define that. Let's call it L3, and we'll say that L3 is, well, we have to define it according to this given structure up here. So we'll say it's a list node, and its value will be 0, and the next value will be none. Okay. Next, what should we do? I guess at this point we start just iterating through the linked lists. So when are we going to stop? Well, we're going to stop once both of these are both of these ones are completely iterated through. And how do we know when that's going to be the case? We know that's going to be the case when the next values in line are none for both of them. So while one of them is still empty, one of them still contains a value, we should still be okay to iterate through them. Again, the given example here only gives us two linked lists of the same size, but it doesn't say that that's always going to be the case for the input. We could very well get something where like this is just a 3 and this is a 5, 6, and a 4, and that's why we need to check for if one of them still has a value rather than if they're both empty. So what we should do then is you should say while L1 is not equal to none, or L2 is not equal to none. And then what should we do from here? Okay, we're gonna want to start adding. So let's just make something called temp sum, and let's set that equal to the values of L1, the current ones that we're looking at, and we need some kind of carry element just in case we run into situations where we're carrying a number. Okay. And if it's the case where temp sum is greater than or equal to 10, we don't want to add temp sum. We want to add temp sum minus 10. So okay, what I'm thinking here is if we were to do something like this, we run into a bit of an issue because at the very end when we're returning L3 here, we're actually not going to be returning the wanted list. We're just consistently going to be editing this first node, and that's not what we want. So let's define a node that's for now equal to L3, and set this. We're going to be changing this through every iteration. We're going to set this to the next value in L3 after each run. And if this is greater than or equal to 10, well, obviously we have to do temp sum minus 10, and we have to set carry to 1. And if that's not the case, then we simply just add temp sum, and carry will be 0. Okay. What next? So after this is all said and done, we have added a new value to this, to L3 here, but we need to, on the next iteration, change what we're looking at. So we need to change these values of L2 and L1, and we need to change the value of L3 node. So let's do that. We'll do L1 is equal to L1 dot next. Similarly, L2 is equal to L2 dot next. And L3 node is equal to L3 node dot next. Okay. Well, let's think for a second. At the end of the day, we're going to want to return this, right? So what other problems could we run into? If we are in a situation where L1 or L2 is equal to none, this is not going to work because a none type object has no .val function, obviously. So we do need to be a little careful here. So we are going to do this. in the event that L1 is none, but L2 isn't, we're just going to redefine this. We're going to make it 0, none. Similarly, no, not else. If L2 is equal to none, then L2 is just going to be this instead. So we won't run into that issue. Okay. That makes me think we're probably going to have some kind of issue here too, though, because L3 L3 node.next is equal to none. So then once we get over here, we're going to have another issue. So what we should be doing instead is L3 node.next is going to be a list node. So then we can actually work with it. Now another problem I have with this is that we can't be doing this all the time, because if we were, then we would be returning 0 at the end of every one. In fact, we would return a 0 at the end of this linked list as well. And we want it to just be 708, not 7080. So with that in mind, we're basically going to say this again. Over here, we're going to check if we're doing another iteration, then this will be the case. I almost just wrote 12. Okay. Otherwise, we just kind of want to leave it as is. Let's run this, see what we are working with right now. Okay, that looks pretty good. Let me also just, before I submit this, print out L1 and L2 over here, so you guys get a better idea of what the linked lists look like. Okay, so you can see that it's got, the first element's got a value, and its next element is another list node that has another value and another next of another list node. So that's basically what these look like. We're working within this context here. Okay, so let's try and submit this. I'm not really confident that this will be completely right, but I can't think of any other target cases that I'm missing right now. So let's see what we're working with. Okay, interesting. So if we are given 2 5s, then we should be returning, obviously, a linked list that represents 10, but instead we just have 0. And that's because the way this is currently defined, we're finishing once these are both empty. So what we should do also is, if this is not the case, and let's say carry is equal to 1, because in this situation happens here, where we are done looking through the linked lists and carry is equal to 1 in this situation, then we should do something where we add 1 to this linked list, to L3, I should say. And how do we do that? We will do it like how we did it up here. So we do L3 node.val is equal to, no, I should do this, .next is equal to list node 1, none. So if we have this, then let's just try it. I think hopefully this should work. Okay, nice. Let's try and submit it now. Oh. Okay, so now I've actually, I fixed that case, but I've ruined the general case. So I don't know why I just wrote carry equal 1. I should do if carry is equal to 1. Then this happens. So let's try this again. And then let's try to submit it. I hope this will work. Beautiful. And look at that. The runtime's pretty solid too. I think the runtime here is just basically, I mean, we're just parsing through the linked list, so it just should be O of n, I believe. But anyway, thanks. I hope you guys enjoyed this content, and remember to like and subscribe if you want to see more videos just like this. And so have a good day, everyone.